All right, guys, this is Mrs. Lyons, and today's video is going to be day 4 notes. And what we're talking about here, we're going to continue on with our working with the mole. And today we're going to talk about, I guess, what we've talked about in the past is being able to convert from mass to moles using the molar mass. We've been able to convert from particles to moles using Avogadro's number. And today we're going to find out that we can convert from volume to moles. So if we have a gas with a certain volume, we're going to be able to determine how many moles of gas that is. Okay. And then we're also going to apply this to some two-step problems. Not just being able to go from moles to volume, but being able to go from atoms to volume, or maybe even mass to volume. Okay, so here we go. So for 1 mole of any gas at STP, of course, what the heck is STP? For 1 mole of any gas at STP, the volume, okay, in other words, the space that the gas takes up, the volume occupied will be 22.4 liters. So that's another number you need to kind of keep in your mind, keep and know what the volume number is. Okay. Now, these letters are letters and words that you should just come to know. STP means standard temperature and pressure. Okay, so let's write that down. Standard temperature and pressure. So when we say standard temperature and pressure, what we're talking about is a set of conditions. And that set of conditions is going to be 0 degrees Celsius. Okay, so a temperature, standard temperature is 0 degrees Celsius, and standard pressure is 1 atm, which is 1 atmosphere. Okay, so whenever you see those letters STP, that means standard temperature and pressure. Okay, and at those conditions, all right, here's the conversion factor. 1 mole of gas. It's important to note we're talking about gases, so this doesn't exactly apply to solids at room temperature. Okay, since standard temperature and pressure is 0 degrees at 1 atmosphere, we have to be talking about a gas at room temperature. So 1 mole of gas is equal to 22.4 liters of gas. Okay, so again, we can just jump right in and do a couple of problems. Okay, so this example says, how many moles of helium gas will occupy a volume of 149.3 liters at STP? Okay, so let's write out what we need to know. Our given is 149.3 liters of helium. All right, we are looking for moles of helium. Okay, so we're going to set up our conversion. Hopefully by now, you guys, these conversions are easy peasy. If they're not, we need to get you to practice so they get easy peasy. All right, so we start with our given over 1, and then we need our conversion factor. Okay, our conversion factor is 1 mole is equal to 22.4 liters. So in this case, since liters is on the top, I'm going to put 22.4 liters on the bottom. I'm going to put 1 mole on the top. Again, Notice that just as in the other conversions we were doing, the number that goes with moles in all of these cases is always 1, okay? So let me get out my calculator and do the math. So let's see, 149.3 divided by 22.4, 6.66517. How many sig figs? I can have 4 sig figs, so 6.665. My units are moles of helium. All right, shall we do one more problem together? Let's see, I guess we're not gonna do another problem quite yet. We're gonna talk a little bit more. And then I'm gonna give you a beautiful mole map. Okay, so 2-step conversions. And this is just kind of combining everything that we have done so far. All right, how to convert moles to particles. So the thing you've got to remember, the conversion factors, okay? So when we're talking about particles, 1 mole is equal to Avogadro's number, or 6.02 times 10 to the 23rd particles. Remember, particles can be atoms, molecules for covalent compounds, or formula units for ionic compounds. All right, and then if we want to convert moles to grams, our conversion factor is, and this is the only one that the conversion factor is not a set number. In this case, 1 mole is equal to the molar mass in grams. And we get that from the periodic table, okay? And then finally, our newest conversion is 1 mole is equal to 22.4 liters, okay? Now, if you look at this handy dandy diagram at the bottom, it gives you a guideline. It gives you, I call this the mole map. And if you look at your problem, and we're gonna do an example problem down here. If you look at your problem, if you start with your given, so you're going to start with mass, particles, volumes, or moles, okay, and then you're going to convert, okay. What did I do? Uh-oh, my map is wrong. If I want to go from moles to mass, I will change this on your copy. It's going to be molar mass. Hold on. It's going to be molar mass over 1 mole. So my conversion was back upside down. The key here is that whatever you're converting from is on the bottom. Whatever you're converting to is on the top. Okay. Now, while this is a nice, handy little visual for you, you will not be able to use this on a test. Okay. So while you're practicing and getting used to this, you can use this as a reference. But just remember, in the back of your mind, you want to start learning the conversion factors without this tool. All right. So let's do an example. What volume would 4.32 times 10 to the 23rd atoms of krypton gas occupy at STP? All right, so our given is 4.32 times 10 to the 23rd atoms of krypton. And I will not require you to write the element or the substance, although it's going to be a really good habit to get into, because when we get to stoichiometry in a couple of units, it's going to be really important to write down the substance as well. Okay, what are we looking for? We are looking for the volume. So we're looking for liters of krypton. Okay, so I'm going to set up my conversion. 4.32 times 10 to the 23rd atoms of krypton. Okay, that's my starting number over 1. Now, to set up the conversion, if I look up here, I'm starting with atoms. Okay, so I want to go from atoms to moles. So I look, my conversion factor is going to have atoms on the bottom. So 6.02 times 10 to the 23rd atoms is equal to 1 mole. All right, and ultimately I want to get from moles to volume. Okay, so I'm going to put, in this case, and this is still showing atoms cancels. I want 1 mole on the bottom here, so moles cancel. And then I'm going to do the volume, so it's going to be 22.4 liters. All right, let's get my calculator. Turn it sideways so we can do exponents. All right, so I've got 4.32 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times 22.4. So my answer comes out 16.0074486. How many sig figs? My given has 3 sig figs, so my answer can have 3 sig figs. So it's going to be 16.1 because I round up, so 16.1 liters of krypton. All right. Let's see, should we do one more example? Yes, let's do one more example. Oops, I lost the example that's in the notes. Let's see. Oh, I'm confused. I'm looking at my computer for the notes. All right. And not at the papers. Okay, so sorry about that. Let's see. So these are just going to be, I'm going to skip down here. I'm going to hop way down here in the homework. And let's see. What volume? I guess these are all pretty much just one step mole conversions. They are. Okay, so we're just going to pick number 5. Okay. How many moles of xenon gas would occupy 37.8 liters at STP? Okay, so my given is 37.8 liters. My unknown is moles. Okay, so I'm going to start with what I have given, 37.8 liters over 1. And then this one, I only need one conversion because I'm going from liters to moles. So I know that 22.4 liters is equal to 1 mole. Liters cancels out, leaves me with moles. Let's do the math. Okay. 37.8 divided by 22.4. I get 1.6875. I can have 3 sig figs in my answer. So my answer is going to be 1.69 moles of not krypton, xenon. All right. So there you go. I would like you to complete the rest of this worksheet for homework, and I will see you in class.